Let's continue our program of foundation engineering. We have started chapter number 2 in city soil testing. Okay. In the previous video, we have done this part, introduction of subsurface exploration. Okay. In this video, we will talk about this need for in situ testing. It will be mainly about sampling, soil sampling. Okay. Yeah, let's go. So when you do a borehole like this, it can help you to get some kind of soil sample, like this kind of soil sample. Okay, this kind of soil sample can help you to do like visual classification. You can know that maybe this is sand, this is clay. Okay, but this visual classification is not enough. We need to obtain the type of soil, the strength of soil, deformation property of soil, okay, for our foundation design. Okay, for that, because of that, we need to take soil sample while you are making progress, like when you are going deeper the borehole. Okay, you take soil sample from time to time. Taking this kind of sample is good, but not enough. Okay, so we have also this kind of sampling, this kind of soil sample that are much better for getting advanced soil property. Okay, to easily obtain this kind of soil sample, we can call it easily obtain disturbed sample. This kind of sample can be used for soil classification, index, and compaction. Okay, you can use this for making Proctor compaction. Okay, but if you need to determine compressibility of soil or shear strength, maybe internal friction angle, Young modulus, cohesion. Okay, this kind of sample cannot help you enough. You need advanced lab testing or in situ testing, or you need this kind of sampling. Okay, this kind of soil sample can call like maybe undisturbed sample, but this kind of sample we cannot use it to obtain the compressibility or shear strength of soil. Okay, so in this video we are going to mainly talk about this kind of sampling method, different type of sampling, and we can see the degree of disturbance of this sample and how we can use, how we can obtain perform the sampling. Okay, sampling methods. Okay, so disturbance, I was talking about the sample disturbance. So in situ testing is a very, very important phase of soil investigation or of site investigation, because this is the phase where we get the very important parameter that can help us to evaluate, to design our foundation. Okay, parameter that can be evaluated to be a relatively higher degree of reliability than, let's say, lab condition in situ testing. So that is just to say, this is very important phase for obtaining good soil parameter that are very crucial, important for design. Okay, because the reliability of the and accuracy of parameter obtained in lab will highly depend on disturbance of soil sample. Okay. However, if you do, for example, CPT test or SPT test, this is in situ test. The information you are getting from these are much reliable than the information you are getting in the lab, means soil parameter you are getting in the lab, because the soil sample are disturbed. Okay, the degree of disturbance is maybe different from this one or this one, for example. Degree of disturbance is different, but they are still disturbed sample. Okay. So in lab, you take the sample from the ground, from the underground. During the sampling, okay, it can cause soil disturbance. Transportation means from the site, the investigation site to the lab, it can cause disturbance. Okay, extrusion can cause disturbance. Preparation process also can cause disturbance, because when you take this sample, for example, if you go in the lab, you have to prepare the sample before testing it. Okay, this preparation also will cause disturbance. So there are many factors that are causing uh, sample disturbance. That's why the in-situ testing, okay, when I say in-situ testing, I'm talking about like CPT or SPT, this kind of in-situ testing are giving more reliable soil parameter than lab testing, because lab testing reliability depend on the soil sample itself, if the soil sample is disturbed or not. The degree of disturbance of this soil sample will determine the reliability of and accuracy of the design parameter obtained from lab. Okay. So as I say, there are many factors that are contributing to the sample disturbance. And in the next slide, we are going to see what are these factors. The first one, number one, okay, we have up to at least four. There are much more, but here we are going just to see four of them. Number one is the use of samplers, the equipment you are using. If this equipment uh, has a high metal percentage in the cross section, this means that the ratio of the internal diameter and the inner diameter and outer diameter are like too large. It means the thickness of the simpler the sampler is very large, for example. Okay, I'm not sure if you understand what I mean. It depends on this diameter, the outer diameter and the inner diameter of the equipment you are using for sampling. Okay, if the sampler is having high metal percentage in cross section, then it will cause sample disturbance. Okay, yeah, so we have to calculate this ratio. It called area ratio for of a sampler, which is defined by this formula. Okay, so DO and DI are respectively the external and internal diameter of this simple sampler. Okay, so a very common sampler use this one, the standard split spoon sampler. This one is related to SPT. The sampler you are using during SPT is this one. Okay, and the another one is like this kind of sampling method. This SPT samplers means the standard split spoon sampler. The value of this area ratio, the area ratio is very high, is higher than 100, around 113, 15. Okay, so you will see that this kind of sampling is giving very disturbed soil sample. Okay, so we have also this kind of samplers. We call them Selby tubes. Okay, these salvage tubes are much more reliable. They're giving less disturbed soil sample. Okay, I will define here, give a definition of this again. The high metal percentage in the cross section. If we consider this cross section, for example, okay, you see the area of the metal and the area of the soil. Okay, if the area of the metal is high, for example, if the cross section of the pie is very high, then it will affect this ratio. The soil will be disturbed. Supposing, for example, the inner diameter here is very small, smaller than the outer diameter, then you will have the cross section of metal, like the inner diameter is around here. Then all this will be metal. I hope you understand now what is the meaning of high metal percentage in the cross section. Okay. However, if this metal is very thin, okay, then it is very low metal percentage in the cross section. Okay, as you can see, this kind of Shelby tubes, they have very low metal percentage. These are here. Okay, we will come back on this later. This is just for illustration. So these kind of tubes can have then the area ratio around or less than 15%. So it is very good compared to the soil sample you are obtaining from standard penetration test. Okay. So number two. So number one that is causing, the first factor causing the soil sample disturbance is this one. Okay. This ratio, the area ratio. But it is not the only one. Okay. Number two is friction between internal sampler wall and the collected sample. It means inside the equipment, inside the sampler, there is friction between the soil sample and the sampler. That friction also can cause sample disturbance. Okay? Because it will cause compression or shortening of the soil sample. That's why if, for example, the friction is very high, if you push, because this is how it works, you are pushing the sampler in the ground. So if the friction is high, then the sampler will compact the ground. Okay. So this can be addressed, this issue can be addressed by introducing a minute inward protrusion of the cutting edge of the sampler. Number three is loosening of the sampling due to the roots, sometimes roots in the soil or air in the soil. Okay, because when you remove maybe the air that was in the soil will escape, for example. The air that was trapped in the soil will escape. Okay, so that will affect also your sample. So the effect, of course, the cause is number two and number three. Means this one, friction and loosening. Okay, this can be evaluated by recovery ratio of the collected sample to define, which is defined as this one. Okay, recovery ratio, LR divided by DP. Okay, recovery ratio in this formula the DP and LR are depths of penetration of the sampler and length of the collected sample. Okay, the depth DP, this one, is depth of the penetration of the sampler and the length of the collected sample, respectively. So we have here this value LR. If this value LR is close to 100, then we can assume that the minimum disturbance, sample disturbance is obtained. Okay. But if this value is very far from 100, it means the soil sample is disturbed. Okay. And here is definition of this. For example, we have here a sampler. This one is actually for SPT. Okay. And you see here the soil length in this is the sampler and this is the soil sample. And the soil sample length, the length of this one is what we are calling here LR. And the total length of the sampler is this one. As you can see, all this area, there is nothing, there is no soil here. So it's the LR is shorter than DP. DP is maybe the depth of the penetration of the sampler. Okay. This is the purpose of this, just to explain this. Okay. We will come back on the SPT sampler later. So we can evaluate how disturbed was the soil from this. If it is close to 100, then we can assume, we can say that our sample is, the disturbance of our sample is small. Okay. So number 2, number 3, then number 4. Number 4 is about evaporation of moisture in the soil, in the sample. Okay. When you are transporting the soil sample from the site to the lab, this water in the soil sample can evaporate. Okay. And that will cause like shrinkage, and it will cause the soil particle to rotate, reorientate in the soil sample. Okay. And it will also change, of course, the density, because dry density and wet density are not same. Okay. So this can be eliminated by wiping and sealing soil sample during transportation to the testing lab. Okay. You have to cover it very well so that the water will not evaporate from the sample. Okay, these are 4 main factors that are causing disturbance of soil sample. Some of them can be corrected, actually. Okay, but there are also many other factors. We are not sitting here. Now we are going to see the procedure for sampling soil. What are different methods for getting soil sample? Okay, there are also many methods. We are going just to see some of them here. But no matter the method you are using, we will have 2 types of soil sample. 2 types. We have disturbed one and undisturbed one. I think I have already talked about that. Disturbed sample and undisturbed sample. Okay. So here, for example, we can say that this is disturbed sample, highly disturbed sample. But maybe this one is maybe undisturbed sample. But this one also is still disturbed, but the degree of disturbance of this one is much less than this kind of sample, for example. Or the sample you are obtaining from the SPT spoon sampler. Also, that one also is disturbed actually because the area ratio is higher than 100%. Okay, so two types, disturbed sample and undisturbed sample. So for the disturbed sample, disturbed one, this one, or for example, or the SPT one, for example, they are disturbed, but they are still representative. This kind of sample can be generally be used for the following lab tests. I think I have already explained that. You can use it for grain size analysis, okay? For granulometry. You can use it for the liquid and plastic limit, okay? Let's say Attenborough limit. You can use it also to obtain the specific gravity of soil. You can use it to obtain the organic content of soil. You can use disturbed sample also to obtain classification of soil. Okay. Soil classification. You can use this kind of soil sample, for example. Okay. But disturbed sample cannot be used for consolidation, for example. It cannot be used for obtaining hydraulic conductivity of some soil, for example. It cannot be used for obtaining shear strength of soil. Soil shear strength tests. Okay. Triaxial test. You cannot use this kind of sample to obtain triaxial test. You can use this one, for example, the Shelby tubes sampler. Okay. So undisturbed soil sample must be obtained for this type of lab testing, this kind of lab testing. Consolidation, hydraulic conductivity, shear strength tests. Shear strength tests, there are many. Okay. So you can use this kind of soil, undisturbed soil sample. Okay. So in the following section, we are going to describe some procedure, some ways for obtaining soil sample during the field exploration. Okay. First, we are going to talk about split spoon sampling. This one is directly related to SPT test. Okay, so we will come back on this SPT test. But here in this video, we are just going to talk about the sampling, not the SPT test itself. Of course, we are going to talk about the SPT, but we are not going to go deeper on the end value. Okay, we just want to show sampling, how the sampling during the SPT works. Okay, so this spoon, the split spoon sampler, can be used in field to obtain soil samples that are generally disturbed. As I was saying, the soil sample obtained from this SPT are disturbed sample. As you can see, we say that the area ratio is high, very high, higher than 100%. Okay, but the soil sample are still representative, can be used for a soil classification index, like limit, liquid limit or plastic limit. Okay, or this kind of, but cannot be used for like compressibility, for example, or the strength testing for obtaining soil strength. This kind of test, we cannot use it. Consolidation, hydraulic conductivity, and shear strength. Okay, so a section for this standard split spoon sampler is shown here. Okay, so you can see this. Maybe the length is higher than this, longer than this. So sometimes we use this device inside. Okay, to obtain, to prevent the sample to go away. I mean, to keep the sample inside the sampler. Okay, so these are the standard spilled spoon sampler, and this device, only this one, this inside is the spring core catcher. Here is photo. The sampler is here, and this small device inside is this one. It will help to keep the soil sample inside. Okay, as you can see, if you place this inside in this way, when you are sampling, the soil sample can easily enter. But once it enter inside, going out will be difficult because of this. It will keep the soil sample inside. Okay. So we don't have to use it anytime. There are only some specific soil that needs this. Okay. For example, sand or sand under water level. So this is the sampler itself. Okay. So how it works, we are going to see how it works. But first, what can we say about this sampler? This is the steel driving shoe. We are calling it steel driving shoe. It is just this tube, this steel tube. Okay, this tube is here, as you can see. And we can longitudinally spell it in half. Can you see? We can open it in this way. Okay. And this, we have coupling at the top. This coupling is this part. This part is helping us to connect this tube, this sampler, to the drill rod, okay, so that we can perform the the test. Push the sampler in the ground, okay, and the dimension, the inside diameter, this tube is about 34.93 millimeter. The problem is this is normally American standard, like it is, the dimensions are in inches, so we have to convert them in like millimeter or centimeter sometime. That's why we have a lot of, the value are not round value, okay, but it's okay, I think. The outside diameter, as you can see here, this one is 50.8 millimeter. Inside is 34.93 inside that. Okay, so the sampler, this kind of like the length of the sampler and diameter, this diameter sometimes can change. We can have, for example, 63.5 millimeter for the outside diameter, and sometimes 76.2 millimeter. We can have these ones. So the size is not fixed. There are different types. Okay. So how it works, how we do the sampling using this spilled spoon sampling. When your borehole is extending, okay, when you are going deeper using your borehole, okay, the drill tools are removed. You remove it and you fix the sampler on the drill rod. The drill rod, you fix the sampler there, okay, and you can just lower the sampler down the bottom of the hole, your borehole. Okay, this is how it works. So you make the hole like this first, okay, and after making the hole, you remove this, okay, the drill tools. After removing it, then you fix this sampler, okay, the spoon sampler to the rod. Then you put it down at the bottom of your hole, this hole, okay, as you can see like this. Then after that, you can just drive this sampler. You see the hole is here, for example, illustration is here. At the beginning, you are here, and this is the sampler you have, okay? Your intention is then drive this sampler into the ground. As you can see here, the level of the hole was here. Then you now start driving, okay? By using a hammer, just lifting and dropping a hammer. And while you are dropping the hammer on this here, the oven, the tube is being driven in the soil, okay, like that, until this distance. We will explain this distance later. So the weight of the hammer, this hammer, is about 622.72 newtons. You can convert this in kilonewton, okay, in kilonewton. In kilograms, sorry, maybe around 63.5 kilograms. It just by dividing it by the G, the gravity, okay? And for each blow, when you're dropping, the height for dropping the hammer is around this 0.762 meters. Or you can just say in centimeter, can put it in centimeter, around 76. Sometimes people say 75 centimeter, okay? So this is this distance, okay? Or this distance, the hammer is here, and the distance for dropping the hammer is 75 here, or 76.2 better, 76, okay? The problem is the conversion from inches to meters. So by dropping, you're driving the sampler into the ground. This is a photo of this test these people are doing. So the number of blows, because you have to count the number, how many times you dropped the hammer, and the depths you are obtaining. You have to record both, okay? So we need to record the number of blows that were needed for the penetration of the spoon for 3 times this depth, okay? 152.4 millimeter when we convert it from inches or to millimeters, okay? Or you can easily, some people just easily say 15 centimeter, okay? 3 times 15 centimeters interval, okay? You have to count how many blows. As you can see here, 1, 2, 3, 15 centimeter, or 0.15 meters, 0.15 meters, 0.15, 3 times. So you have to count how many times you dropped the hammer, okay? And then the number of blows that were required for the last 2 intervals. The last 2, these 2, 1 and 2, okay? It means you will count, of course, for the 3 intervals, the number of blows for the 3 intervals, but you will keep only, okay, the blow count for the 2 last intervals. Do you understand? You have 3, but you count 3, but you retain the count for the 2 last interval as the standard penetration number. N value, okay, at that depth. So this number is what we are calling N value, according to the American standard, this standard, American Society for Testing and Material. Okay, this is how it works. This is what we are calling N value. We will come back on this in the next video to see how we can use this information, N value, to obtain soil parameters, in situ soil parameters. Okay. Then after doing all this, until here, the end, after reaching this, you remove the sampler. The sampler is then removed, withdrawn, and the shoe and coupling. Do you remember what we call shoe and sapling? You just remove it from the road. Okay. Finally, the soil sample are recovered from the tube like this. You can see after removing it, you can open, okay, the sampler, spill it in two, and open the soil sample. The soil sample can be recovered from there. Then you place the soil sample in this kind of like containers. It depends. Some people use this, some people use this. There are different. Then you can transport this into the lab, okay, to perform your lab testing. So this is what we are calling standard penetration test. We are going now to estimate the degree of disturbance of soil sample obtained from standard penetration test. Okay, so do you remember this formula, the area ratio? And we say that if this area ratio is high, close to 100, then your soil sample is highly disturbed, a highly disturbed sample. Okay, so in this area ratio of disturbed area to total area of soil, okay, DO, this one is the outer diameter of the sampling tube, and DI is the inner diameter of the sampling tube. Okay, so in the case of the SPT, spoon sampling, the outer diameter is this 50.8 millimeters, okay? And the inner diameter is 34.93 millimeters, okay? So according to that, if you use this formula, here is what we are obtaining. You can see that this is higher than 100%. It means your soil sample is highly disturbed, the sample you are obtaining from SPT, okay? And when the area ratio, this ratio is around 10% or less, then your sample you are obtaining is considered to be less disturbed or undisturbed, okay? So in our case of SPT, we are having around 111.5. That means the soil sample obtained from SPT are highly disturbed sample, okay? I hope you understand now. Next, this is just for your information, interval of about 1.5 meter. But when the material you are using, when you are using this spoon sampling from SPT, and on your side, you have, in the field, you have sand, especially if you have sand below water table. In that case, using this method, using this spoon sampling may be very difficult. Not using it, not difficult, but taking out the soil sample is very difficult. And you have to use, in that case, what we are calling, the device we are calling here, spring core catcher. This device, okay? I think I have explained this before at the beginning of this video. So by using this, it will help you to retain, keep the soil sample, the sand, inside the tube, okay? For entering, it will be easy, as you can guess. But coming out, the sample will be, it will be difficult for the sample to come out when you are pulling out the road, okay? So let's go for another type of sampling, okay? What is this? A copper bucket. So this method, when the soil deposit are sand mixed with this pebble, for you to obtain sample but by this SPT sampler, the spilled spoon with spring core catcher, it means this method using these tools. When you have this kind of mixed sand with this kind of material, it is difficult to withdraw your sample, to obtain your sample. For this kind of material, you have to use this kind of sampler, okay? This sampler is maybe used to obtain disturbed representative sampler, but it will be still disturbed sample, okay? Here is a photo and a like a drawing of this sampler. This cross section SS is this like C. So you can see it is here, like there is opening here, and it has a driving point, okay? It has a driving point and can be attached to the drilling rod. This point, you can attach it, drilling rod, you can attach this point to the, like the road, the same road you are using for SPT, for example, the drilling rod, okay? You can see here the opening. So the soil is entering from here when you are driving this driving point, and here is the opening, that is the same opening that is represented here. So the sampler is driven in down into the soil and rotate it. So you put it down and you rotate. While you are rotating, it is collecting soil sample, okay, from the side. So another sampling method is sampling with thin walled tube. This is the Selby tube we talked about before. This kind of tubes are, as I said just now, Selby tubes. We talked about this before, right? Okay, you can see here and many of them, okay? We just attach this to the end. So the advantage of these are just you can close the both ends of this tube and transportate the sample directly to the lab, okay? It will help to keep the water inside, okay? It's less disturbed than the SPT spoon sampler. Soil obtained from this SPT spoon sample. So they are made of like seamless steel and frequently used to obtain undisturbed clay soil. Undisturbed clay soil. And here also you can see this equipment that can help again to keep the soil sample inside the tube. So most common of this Selby tube have this diameter 50.8 millimeter and 60 76.2 millimeter, the outer diameter. Okay, there are maybe mainly these two diameters, but maybe you can have more. So it can allow, it has possibility to attach this, as you can see, this device allow you to attach this tube to the drilling rod. Okay, because it has this sharpened end. Okay, and you attach this to the rod for this kind of, for example, this. Okay, you attach it to the drilling rod and you insert this tube into the ground. Okay, so the drill rod with sampler, then sampler attached is lowered to the bottom of the hole, same as the SPT. And then the sampler is pushed into the soil. The soil sample inside the tube is then pulled out. Here is the illustration of how it works. Okay, so the two ends are then sealed. The two ends of the tube are sealed like this. You see this end is covered, this end also is covered, and we take it like that and go in the lab. Okay, and the sampler is sent to the lab for testing. Okay, this figure shows the process, how it works. Here you can see how this tube is attached to the rod, drilling rod. Okay, and then you lower it down into the hole, the borehole, and you push the tube into the ground. After that, you pull out the tube with the soil inside, which means you have collected the soil, and then remove it and close both ends and take it like that to the lab. Okay, so how disturbed is this sample obtained from Selby tubes? Okay, so soil sample obtained in this way can be used for consolidation or testing, share testing, because they are considered to be less disturbed. Okay, so if we consider, we have seen that they have there are maybe two diameter, outer diameter of this sampler. If we take the one that has 50.8 millimeter as outer diameter, the inner diameter for this type is 47.63 millimeters. So you remember this formula, right? We can calculate the area ratio, degree of disturbance indicator. So this area ratio, you know already the meaning of this. So by using this dimension, we can calculate the area ratio, which is here 13.75%. And you remember this saying that when the area ratio is 10 or less than 10%, the soil sample is generally considered as undisturbed. Okay. Sorry, here. So we can say that this soil sample here obtained by this method are maybe almost undisturbed. We can say it. Okay. We can say that these are undisturbed because it very close to the 10%. But there is another method, sampling method, that gives much lower value, that are using the same method, almost same method, but just adding something to make it more special. This is this method, piston sampler. this sampler is similar to the Selby tubes, using maybe same type of tube, but this piston is making the soil less disturbed than the Selby tubes. Okay, so when you are using like a very large diameter sampler, okay, undisturbed soil are very and the undisturbed soil are very like soft soil, then these the Selby tubes are sometimes not very good. Okay, so when we have this situation where the soil sample are very soft and the diameter of the tubes are like larger than 76.2 millimeter. Okay, the soil sample are tending to fall out of the soil sampler. Okay, they're coming out easily when the diameter is large, which is normal. So this piston sampler are particularly useful for this kind of situation where the soil is soft and the diameter is larger than 76.2 millimeter. This is illustration of this piston sampler. Okay, this is just a drawing, and here is a photo of this. As you can see, this also can be attached to the sampling load. Okay, so it's using, there are several type of these actually, but these proposed by this reference shown here are a like more popular in in use. Okay, so as you can see, it is similar to the Selby tubes, but with a piston. Okay, so initially the piston close to the end of tube. Initially the piston is here, close to this end, and then the sampler is lowered into the hole. The hole is here. See, the borehole is here. So you put it down. Sampler is in the hole. Okay, and then this tube is pushed into the soil using hydraulic force, hydraulically pushed in the soil. Okay, piston is here, and we push it. Okay, when you push, this piston is getting down close to this one, and then you can see a small hole here. This will help to release the pressure. This hole will help to release the pressure. Okay, to a large extent, the presence of this piston, it helps to prevent distortion in the soil sample by not letting the soil squeeze, or also by not admitting excess soil. That's why this piston sampler is very good. It combines the effect of the piston and the effect of this Selby tubes. Okay, so as consequence, the sample obtained in this way, in this manner, are less disturbed than those obtained by Selby tubes. Those obtained by Selby tube are already very good because it is around, the area ratio is around 13%, and this sample obtained by this piston sampler are less disturbed than this Selby tube. Maybe it will be around 10% or less. Okay, so we are going to conclude to finish up the part of this chapter. To finish, we will say in terms of foundation engineering, in situ or in place testing like CPT or SPT or many other methods are those methods that evaluate the performance of geotechnical structure, maybe foundation, or in place property of soil or rock. Evaluating the in place in situ property of soil, CPT can give you that. For example, CPT, for example, or SPT, test N value. Or evaluating the performance of foundation. When you are going to do loading test, for example, on foundation, this is the evaluation of performance. This is also in situ testing, actually, because some people are seeing in situ testing just like CPT or SPT. Loading test, pile loading also is in situ testing. These are what we are calling in situ testing. Okay, so this testing can range from soil boring or at a survey location to monitoring the response of, as I was saying, fully loaded bridge pier, for example, or dam, monitoring dam also, or other foundation element. Okay, the reliability of the given structure to function as designed is directly depending on the quality of information obtained from such testing before design. Okay, this kind of testing will determine the reliability, the performance of the structure after being constructed. So if this goes wrong, everything will go wrong. Okay, even if the structure is like robust, very good, very strong. If this is not good, it means the foundation will not be good and it will collapse eventually. So it is very important that as geotechnical engineer, you be familiar with this type of testing and the procedure for execution of this testing, as well as associated advantage and disadvantage of them, because they are not same. You have to know the advantage and disadvantage of each of them. Okay, and when to use them. So this method of this in situ evaluation can be sometimes invasive or non-invasive, invasive, I will say, destructive, non-destructive, and they may also or may not recover a specimen. For example, if you do SPT, CPT, you don't need to take soil sample, right? For visual confirmation or lab testing, if you do SPT, you can take soil sample. Okay. In case of invasive test, for example, you can see soil boring or penetration test. This kind of testing are like time consuming, expensive, but precise. But if you take non-invasive test, for example, ground penetration radar, we are going to see this in the next video, or seismic refraction, this one also in the next video. Okay, these provide large amount of information in short period of time, so less time consuming. Okay, but typically less quantifiable. However, if we use like for collectively this kind of we use them together, these two methods, okay? If they are used together, the two methods can be, they can complement each other, okay? They can complement each other and define area of concern from these non-invasive techniques, and secondly, determining the foundation design parameter from invasive techniques. So this is particularly advantageous in large sites where extreme variation in soil structure may exist. Okay, all relevant in city tests except plate load tests are discussed in this chapter. It means everything related to in-situ testing we will discuss in this chapter. And only this one, the plate loading test, will be discussed in the chapter, maybe chapter 4. Okay, it's plate loading test in the case of combined designing of combined footing. Okay, so get ready. Everything about in-situ testing, as you can see here in the content of this chapter, we have everything almost, except we did this introduction, and this one is what we are doing now. So after this, we will see all these in situ testing, geophysical testing method, physical sampling, penetration test. This is just SPT, okay, cone penetration test. All these testing, field testing, will be discussed in this chapter, okay? So that is the end of this video. Thank you very much, and see you soon.